Hello everyone. Today let's solve the problem number 322, coin change. So what the question states here, we are given an array coins. You can clearly see here we are given an array coins where each element represents a different coin denomination. So here each element represents different coin denominations. Means this is, if you consider this one in rupees, this is 1 rupee, this is 2 rupees, and this is 5 rupees, right? So where each element represents a different coin denomination. We have an integer amount. You can clearly see here we have an integer amount representing the total money. So this is the total money, right? So we have the integer amount representing the total money. What we need to do here, we need to make using these coins. So we have to use these coins to reach this coin. So here you can clearly see how you can consider any coin here. You can consider 2, you can consider 5, you can consider 1. That should sum up to 11. You can make use of the individual coins anytime. There is no restriction for that. You can clearly see here 5 plus 5 plus 1 they have given 11. This is just for the explanation. They have given here output is 3 they have got. Let's see that itself. The goal is to determine the minimum number of coins required to make up the given amount. So we have to find the minimum number of coins that make up to the amount. So by making use of these coins, we have to find out the minimum number of coins that is required to make up the amount. Make up the amount means this one, whatever they have given, amount 11 in this case for this example, right? So if it is impossible to make the, if it is impossible to sum up by making use of these elements to the amount, then we have to return -1. So that's what they have given, right? So this is the question. I hope question is clear. See here, 1 to 5 they have given coins here. Output is 3 because 11, the minimum number of coins that make up to, or that make up to amount here is this one, 5 plus 5 plus 1, nothing but here in this case 3. So we have to return the length or the number of coins, minimum number of coins we have to return. So in this case it is 3. So here you can clearly see, let's come to the example 2 here. We have only one coin that has to reach up to the 3. At any cost it will not sum up to the 3 at all, right? Sum up to the amount here. The coin does not sum up to the amount at all in any way. So output we need to return here as -1. Same goes with the example 3 as well. 1 we have amount they have given 0. 0 they have given. So it will be 0 itself, right? So that's what. So consider this one, consider this one, and consider this one. I hope this one question is completely clear, right? So initially what we'll do, we'll discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written, right? So initially let's discuss the approach. Let's discuss the approach step by step here. In this case, we'll be making use of the dynamic programming, right? So bottom up approach, DP, or we'll be making use of the dynamic programming. So we will be considering the first example that they have given in the question itself. I have considered first example that they have given in the question itself, right? So here what we will do initially, so this is the initialization step here. Initialization, DP, we are considering the DP array and we are initializing this one with the first index with 0. We are going with the length amount plus 1 here. Just keep this in mind. So just for the easy computation, we'll be going with the amount plus 1. So we should be having 12 elements, and first element will be 0. We will be initializing this one with 0, and all the elements will be infinity. So it will be infinity actually. We will be this one initializing with infinity. Just for the sake of understanding, I'll just give an infinity symbol, right? So we have 11 infinity symbol because amount we have considered here as 11. From this to this one, this is 1 to 11, and this one is 0 initially. We are going with the size of the arrays amount plus 1 again, just for the easy computation. Just keep this in mind, right? So second case here is we will make use of the first coin. 1, 2, and 5 are the combinations we have here. You can clearly see we have the coin 1, we have the coin 2, and we have the coin 5. So first we will be making use of the coin 1 here, right? So let's update DP for all the values from 1 to 11 here. So initially what we will do, initially we have initialized 0 and 11 infinities, right? So because we were having 11 coins and the size of the array is dp plus 1, I mean amount plus 1. So here in this step, when we consider coin equals 1, let's update the dp for all the values. So how can I write this one? This will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I hope this is clear. Now what we have done, we have updated the dp for all the values from 0 to 11 as we are considering 1 here. I hope this is clear. This is simple, right? Next, let's go with the coin 2. We have to update dp from 2, 3, 11. So every coin consists of this will be 2. Means I can write in this way. Let's update the dp array. You'll get to know. So initially it will be 0. This will be 2. 1 will be twice here, and 2 will be twice here. 3 will be twice here. 4 will be twice here, and 5 will be twice. As the array sizes, amount plus 1 will be going with 1, 6 here in this case, right? I hope this is clear. So we should be having 12, 12, right? This one amount plus 1 means 11 plus 1, as we are going with amount plus 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We are dealing with the coin 2. So we are considering every coin 2 here. You can clearly see. I hope this is clear. So we have successfully updated the dp array, right? So next we had one more combination of coin here. You can clearly see here this one 5. 1, 2 we have already considered. Let's go with 5. Let's update the dp for dp array for this one 5, 6 and 11. So here what we will do, 0, initially it will be 0. This one will be 1, 1, 2, 2. This will be, this remains same. From 5 what we will do, again we will this will be 0, 1, 2, 3, 4, 5. So from here we will start updating, right? This will be 1, 2, 2, 3, 3, again 2, and it will be 3 here. In this case, this will be 6, 7, 8, 9, 10, 11 and 12. So here at the this one dp of 11 or this one. So did I miss anything here? 0, 1, 1, 2, 2, 1, 2, 2. This is fine, and 3, 3, 2, 3. Correct. This is correct, right? So here in this case, the last element that we got here, dp of 11 here is 3. You can clearly see here this one. The last element here, this one will be dp of 11, right? dp of 11 here we got is 3. That's what we need to return as output here. So in this case, dp of 11 we will return, this will be 3 in this case. This is same as the output they have mentioned for the first example amount 11. So output will be, in this case, output will be 3, right? So this is the approach that we will be going with. So we have made use of bottom up dynamic programming. We have made use of the bottom up dynamic programming approach or bottom up dp approach, right? So I hope this is completely clear. This is the approach that we will be going with. So next, let's discuss the edge cases one by one here. First edge case is for the exact match. Let's consider coins 1 to 5 and output will be 11. I mean amount will be 11, output will be 3. This is the previous example that we have considered, right? So I hope this there is no ambiguity in this. So I hope this is clear. This is for the condition exact match. So the second condition here is impossible case. Means coins only 2 we have, only one coin we have, that is 2. Amount we have to sum up till 3, right? So here it is not possible at all. Output will be minus 1 in this case. So this example we have already discussed in the this one example, right? Example that they have given in the question, second example. So let's move on with the third edge case, nothing but 0 amount. So coins here it is 1, amount here it is 0, right? So output will be in this case 0 as well. This is also, we have already discussed this one in the question. So here coins we have, amount also we have. This is not possible at all because amount is 0, right? So at that point of time the output will be 0. The fourth edge case that we need to consider here is single coin case. Means coins, only one coin is there, that is nothing but 7, and amount we have is 14 here. Output will be 2. Why? 7 plus 7, right? The combination. So this is 1 and this is 2. You can visualize, or you can just try it out in the same way that I showed for example 1 in the approach, right? So next, let's move on with the fifth edge case, nothing but large coin value. Coins we have considered 3. This is 1, this is 2, this is 3. So amount 30 they have given. So in this case, output will be 3. The minimum coins that we'll be making use of here is 3, right? So the minimum number of coins required to make up the given number here is 3 in this case, because this combination will be going with. You can just try out in the same way that I showed for the example 1 in approach. Again, I'm telling. So 10 plus 10 plus 10 it will be. So this is output will be 3 in this case. This is for the fifth edge case. I hope all the edge cases are clear, right? Now let's start writing the code. So before writing the code, what are all the edge cases that we considered here? Exact match, first one. Second one, no possible combination. Third one, amount is 0. Fourth one, just give me a second here, what happened? Yeah, fourth one, single coin case, and the fifth one is finally large coin value. So I hope these edge cases are clear. So now let's start writing the code. So let's start writing the code here. Initially, the step 1 is let's create a DP array initialized with a large value, nothing but amount plus 1, as we have discussed this one. So we have discussed this one earlier, right? So we have seen this one as well. So I'll just go with the unsigned 32-bit integer array. So I'll just give here uint 32 array, just for the memory optimization, right? So I'll just give here amount plus 1. Let's fill this one with amount plus 1 as well. So the next step here is the base case. To make amount 0, we need 0 coins. We have seen this one in the edge case as well as the example while discussing the example, right? So dp of 0, we can just initialize this one to 0. The third step, we have to iterate through each coin denomination, right? So simple for loop here, let c of coins, this one is fine. Again, one more for loop here for let I equals c. Individual coins we are considering here, I less than or equal to amount, and let's increment the I here. So this is where we are iterating through this one for loop. So we are iterating through each coin denomination here. This one, this for loop here, we are updating the DP table for each amount from the coin value to amount. We saw that one from step 1 to step 3, final answer till final answer, right? One for this example we saw for 1, 2 and 5 initialization, 1, 2 and 5, totally 4 steps were there. So that's what we are doing here. So we are updating the DP table for each amount for the coin value to amount, right? I hope this is clear, simple, right? So the next step was, if you remember, we have to take the minimum coins that is needed to form I. So this one I can articulate in the form of code in this way. Iterated value of the DP, this one will be, we have to take the minimum, right? So we have to take the minimum coins that is needed to form I. This will be math.min of iterated value of the DP and DP of I minus C plus 1. This is fine. I hope this is clear. So the final step here is, if we couldn't form amount, then we have to return minus 1. If this one we have discussed in the edge case and during the question as well, right? If we couldn't form any amount, or if the coins couldn't sum up to the amount, or if we couldn't form this one amount, then we have to return minus 1. Otherwise we have to return DP of amount. So the answer, right? DP of amount is nothing but answer. So return DP of amount here, this one. If it is greater than amount, then what we will do, we will this one minus 1. We saw this one here, I think, yeah, in this example. We cannot make up to amount at all by making use of this particular coin. So it will be greater, right? At any cost it will be greater. 2 plus 2 it will be 4. If you consider same, it will be 4. It will never be 3 at all here. In this case we have to display -1. That's what we are doing here. dp of amount greater than amount, then what we will do, we will give -1, else we have to return dp of amount. So this is it. I hope this step is also completely clear, the last one, right? We are just making use of the simple ternary operator with dp of amount. We are just playing with this one, right? So -1 and returning the number of coins. We are just playing with these two right here. So I hope this is completely clear. Let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. Let me hit the submit button. So here you can clearly see all the test cases are getting passed here, right? So the code works absolutely correct. Then let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is bottom-up dynamic programming, or we can just call dynamic programming or DP, right? So what will be the time complexity here? The overall time complexity would be big O of m into n, right? So m into n, when I said m into n, n is nothing but the amount and m is nothing but number of coins here. M is nothing but number of coins and n is nothing but amount here. So what will be the overall space complexity here? The overall space complexity would be big O of n as well. Why it is big O of n? Because we are making use of the DP array here, amount plus whatever we are making use of here. You can clearly see unsigned 32-bit integer array we are making use of here. So because of this one DP array, the overall it requires n space right here. So the overall space complexity would be big O of n and the time complexity is big O of m into n, right? I hope this is completely clear. The overall time complexity is big O of m into n and the space complexity is big O of n. So here I hope whatever the solution that we have written or whatever the code that we have written is completely clear, right? For now this is it. Thanks for watching, guys.